Busu. Tok Tok Wan dah tak ada. Tapi tak apa Busu. Along faham yang Busu tak boleh balik Malaysia sekarang ni sebab COVID. Tapi Busu janganlah risau. Sebab jenazah Tok Wan semua telah diuruskan oleh pihak hospital semalam. Tapi Busu, sebelum Tok Wan meninggal, dia ada meninggalkan kita satu wasiat tau. Tapi wasiat ni dalam bentuk kod. Along dah cuba macam-macam cara nak pecahkan kod ni, tapi tak boleh juga. Jadi boleh tak Along nak minta tolong Busu pecahkan kod ni?
Boleh Along, tak apalah pasal kod tu, Along jangan risau. Nanti Busu cuba usahakanlah, Busu minta tolong staff-staff Busu.
Let's solve for K1. First step, we need to obtain the minor by delete the appropriate row and column. To find the adjoint matrix, we need to find the cofactor matrix. Then find the transpose of the cofactor matrix. Now, find the determinant by expanding the fourth row. Therefore, we can obtain the inverse of K1 by using formula 1 over determinant of K1 multiplied by adjoint of K. Last, multiply the inverse with P, hence K1 is not the correct message as it could not break into any code.
This is the solution for K2 using ERO method. In conclusion, we can say that this method can't be used to solve this matrix because the solution is not equal to the identity matrix in the first step. Therefore, the code generated is not correct.
Next, we will move to the K3 matrix. For the K3 matrix, you can use either adjoint method or ERO method. For this matrix, I will use adjoint method. So, first step, you will need to find the determinant by using column operation. So, determinant that we got after using column operation is 18. Next, we will find the minor and cofactor by using deleting row I and column J. So, this is the matrix of K3 and we will find the minor and cofactor by deleting row I and J. So, the matrix of cofactor that we got is this. After that, we will transpose the matrix by change the column into row and row into column. That's how you do it, which is 40. This is column 1, we will change into row 1. And column 2 will change into row 2. Next, we will find the inverse. To find the inverse, you will need to use this formula, which is A inverse equal to 1 over determinant A that we find for the first step and adjoint A, which is we find after the transpose. So we will start substitute the value in this formula and we got the inverse, which is this. After we got the inverse, we will need to multiply Busu's code that we got in the equation and with the inverse, which is P that Busu code and A inverse, which is we found. So this is the how you do it for the column 1, column 2, column 3, and column 4. So step 6, you need to encrypt the code after we got the multiply matrix. So to encrypt the code, you need to use this table and insert the value of the word this matrix. So the code that we got is Malaysia prihatin. So,